ROS users. Sorry for a slight delay. So I'm Mikael Arguedas, and my colleague Dirk and I are going to talk to you about how we see the use of ROS2 in the future. And so we're going to focus mostly on like capabilities of ROS2 more than like technical details or software architecture. If you want to know more about what is ROS2, I invite you to look at the talks from the last 2 or 3 ROSCons. And you can ask technical questions at the end, but we're not going to focus on the technical parts for the sake of this talk. So first of all, in this, we're going to take kind of like a use case, an example of like our friend Rob. That's Rob, the roboticist, who just bought a drone. And he wants to start playing with ROS2 in that case on his drone. So his drone is already ROS2 enabled. And he decides to start using it. So getting started, he decides to use his laptop, and it can be any operating system, Windows, macOS, or Linux, and he can directly download ROS, install it, and connect it to his drone. So what he's going to do is going to start with a classic teleop concept, and so starting a Python joystick node and a C++ image viewer and connect to his drone. He's going to have 2 topics, one to command his drone, one to receive data, and start flying it around. Of course, flying in his living room is not that convenient, so he decided to go outside and actually try his drone really. But the further he gets from his house, the worse the connection gets, and at some point data is getting really, really slow. And he's missing a lot of images, but mostly his drone motion becomes very jerky because the command is not responsive. And so looking a bit more into the abilities of ROS2, he actually finds out that he can tweak each parameters for each of the topics. And one of the availabilities given by DDS is being able to tweak quality of services. So in this case, he says that his command of the drone is critical data. He wants the drone to receive every single signal on time. But for the images, it's OK to miss a few images. So he decided to switch into a more best effort approach, which is more like the very like UDP, pure UDP side of things, where you can drop frames and you don't try to resend. And so now that he has like this setup kind of working, he's going to start to like do more complex behavior with his drone.
All right, so with the drone now he's able to fly it and gets like decent behavior, so he wants to do more with the drone. And the next step is like he wants to like add hardware to it to make it more capable. And since he's not a hardware guy, of course he wants to buy off-the-shelf hardware, and he looks for hardware which is like already kind of ROS enabled. So he knows that vendor has reputation that the hardware just works with ROS, and maybe even like fully integrated the sensor itself already has a network interface which publishes ROS. So all he has to do is buy the camera, plug it into the drone, assuming it has, for example, Ethernet on board, and the camera will start publishing images. That's what you would like to see from a component. And maybe the camera also offers services beyond that, that you can just go to UI and configure like frame rate, region of interest, resolution, however you like. Of course, now since he has 2 cameras, well, they usually all publish on the same topic. So he wants to be able to just go to that topic and just change the name on the fly. He doesn't want to go into the source code and like change that. He just want to go to the user interface and just remap the topic, give it a different name, and be able to visualize it, for example, on a second image view. That's for just extending the hardware. There's also the software side. Now that he has 2 different cameras, he would like to do something more fancy. And he looks at the ROS package list and finds that there are packages which do like stereo image processing and should be able to detect obstacles. So he's just going to download existing code, an existing package, and instantiate that node at runtime on his drone. And that processing node will then get data from both cameras and be able to like send the results to the flight controller to say, hey, there's an obstacle, don't fly there. Just to recap that first section, Mikael has mentioned in the beginning the advantages. You can use all of that across different platforms. So currently we have it working on Linux, OS X, and also Windows. Windows is usually the pain point if you're working with ROS1. Also, he mentioned that the joystick control and the image view are different languages. In ROS1, everything is written from bottom up, so the Python implementation is not necessarily the same as a C++ one, so you might have slightly different behavior. That's not the case in ROS2. In ROS2, they share a common C implementation, so you kind of get either the same feature or the same bugs, however you want to see it is. Then you have all the quality of service settings, which are mostly coming from DDS, and ROS exposes some of them, but there might be some more which you want to use. You can always reach around the API and like use specific vendor-specific options. And the goal here is that hardware components, because even like a small sensor nowadays has microcontrollers which are powerful enough to do that the hardware just natively talks like DDS, and so a camera can just plug in and publish an image, and you can just receive it. That makes it obsolete to always deal with a custom protocol for every hardware device and a custom driver package, and makes it much easier to integrate. And then the last point is you want to be able to, when a new node comes up, be notified. You don't want to constantly poll the graph for the user interface. You just want to get a notification if something new comes up, just for efficiency. And of course, you want to be able to change those topics at runtime. You don't want to like stop everything, change the argument to your launch file, and then start again from scratch. You want to do that like dynamically. And as the icons indicate, not everything is there yet. Some things are there. Some things we are more like imagining how they should work. So they will come in the future.
Okay, so now that Rob has a drone that he can fly with his awesome stereo camera system, he wants to play a bit more with it. And one of the issues he's facing is that sometimes, now that he has this obstacle avoidance behavior, sometimes when he starts his journey, he realizes that it's not working as he expects. He's very close to crashing into objects and actually has to avoid obstacles manually. And the main issue is that when looking a bit more into it, some nodes are actually not ready. And the obstacle detection, for example, is expecting to have two images to perform stereo and then detect obstacle. But one of the camera didn't come up or was not ready yet. And that's a situation where you can have pretty bad results, which is crashing into trees. So the main goal is to find a way to know if a node is ready or not. And so in ROS1, very often, you spawn services in like a bunch of your nodes and like wait for services to be ready to start working, and it's pretty inconvenient. So what we introduced in ROS2 is this idea of a lifecycle for nodes. So nodes can be managed through this lifecycle state machine, which is when a node comes up, it is unconfigured. When it goes through the initialization phase, create its publishers, everything, once the initialization is done and the node is actually ready, it goes into the inactive state. And then you can flip the switch saying, okay, now I'm flipping all these nodes from inactive to active, and I know they're like fully ready to operate. And finally, when you shut down your nodes, you get them into a finalized state. So if we go back to our previous diagram where like only the right camera was not ready, in this case, if we map that to state, we would actually have every node in inactive state except the camera right, which would be still unconfigured. And in that case, we can just wait for the system to actually be ready to have a deterministic startup and not just a launch file hoping for the best that every node came up. And once we actually receive the notification that every node is ready, we can flip the switch and say, okay, now we're ready to fly. And the main goal is to be able to do all of this through a UI. You have like your graph of like your nodes, and you can just select, draw a box around a set of nodes and say, oh, this should be part of the same startup group. And this way you can actually deterministically launch your nodes.
All right, so Rob has his drone now working reliably, and now his friend comes over, and he also has a drone. Well, his friend still has a ROS1 drone, so he kind of would like to benefit from all the advantages. He saw, hey, I can use it with Windows. I don't have to use my Linux virtual machine to like connect with the robot. And I also want the advantage of being able to configure this like connectivity issues I see with ROS1. I want to be like have the same benefit. So what is he going to do? So well, he could migrate the whole drone to ROS2, but that would be a lot of effort, and they only have the afternoon. So what are the alternatives? We have shown in like the beta 2 we released in July, that we had a robot, the Turtlebot 2, running ROS2. And since we didn't have all the tooling around, we used like the ROS1 bridge, which basically transforms ROS2 messages to ROS1, vice versa. And so we were able to use ROS1 tools like ROS remotely to look at the robot state and send it commands. The recent beta from last week, the beta 3, actually tries the opposite demo. We'll see that hopefully tomorrow in a lightning talk, where we have a robot which runs ROS1, like the use case with the drone. But we want to use the tools and the advantages of the communication protocol for this Wi-Fi connection, for example, coming from ROS2. So in order to do that, we don't want to touch all the code because there's fancy amount of nodes on that robot which work all very well. So instead, we just add to that ROS1 robot another node which consumes some of the topics and sends them out on the other side as ROS2. So the advantage is you don't have to change the existing system and can still benefit, for example, in this case, for the Wi-Fi communication from the ROS2 communication stack. And you don't have to exchange all the topics. In this case, we only needed like the command and image data topic. There's another use case which you can build using that bridge. You can also decide that you want to not only use it for external communication. You can also say, we run the bridge on the robot, and now we pick one certain node, for example, the first one here, I don't know what's supposed to do, and we merge that, we convert that one into ROS2, so we basically move it onto the other side of the bridge. That allows us to like have a larger scale system and gradually move pieces over. Of course, you will have some overhead with like twice the communication overhead as instead of only once, but it's still more convenient to gradually convert your system like this.
Okay, so now Rob and his friends are actually two robots that can speak ROS2. And so they can start exploring what they can do on a multi-robot basis. And most of what we said earlier just applies well or better to multi-robots. Mostly what DDS provides, but also some other middlewares that you could plug into ROS2, like the distributed automatic discovery. So if a new drone comes up, it's gonna like the two nodes are gonna discover, and you're gonna have your two robots knowing I'm publishing my pose, I'm having like all these topics that I'm willing to share, and we can work together. Another thing which is very convenient, especially when you scale the number of robots, is taking advantage of like all the quality of service settings, because very often, like, let's say that wireless communication with many robots is not very, very reliable. And finally, you could also have, in some application, for example, base stations that wants to communicate with every drone or every drone in range. And in that case, leveraging this ability to dynamically remap everything, you could actually remap a lot of topics that you're interested in to a single global topic without having to like change, like restart any node and get all the information in a single place. Or you could also use, for example, something provided by DDS, which is the way we namespace topics. You could actually decide that you want to listen to topic of all namespace, but with that base name, in that case, the pose. And so you could have a system that receives the pose of every robot by just listening to every pose topic, wherever they're located. And so that gives a lot of opportunity for more cooperative and smarter behavior for multi-robot system, because you don't need this centralized way of aggregating information. If a drone comes out of range, nobody is going to know about it anymore. They're just going to assume it's not here. But if it comes back, it can come back and say, hey, actually, this is my obstacle map, and I was exploring this area, so we can like share the workload and avoid exploring the same area again. So this new communication layout is going to be much more convenient for this type of application. And so now Rob has this drone working, talking to another robot, being able to explore. But Rob would like to have this like smarter behavior of like if there is something going wrong, if the drone is running low on battery, to be able to return home automatically. And to do so, he tried to use like GPS data and the localization of the drone, but it's actually not precise enough. So he decided to like add more hardware. and he finds a Bluetooth beacon that he installs in his home and wants to install a Bluetooth receiver on his drone to leverage the data from that beacon. And to do so, he actually knows that he has a Raspberry Pi lying around, which is pretty convenient. And so he starts developing his node in C++ on the Raspberry Pi using ROS2 to take the data from the beacon and develop this return to home behavior. But then, once the node is like working properly, he still finds like a bit too much to add a Raspberry Pi to his drone just to be able to receive Bluetooth. And if only there were like a ton of sensors out there that were already doing that with a small MCU on board. And so he decided to actually buy one of these, ditch the Raspberry Pi, and use microcontrollers that can just like be programmed in C++ and can read Bluetooth data. And he's pretty happy to surprise that because ROS2 runs on microcontrollers, he actually doesn't have to change anything in his code. The only thing that makes sure that the MCU is reading like the right registers for Bluetooth, but the code itself, getting data and estimating a position, is the exact same code. So now that he has like this ability of having the beacon estimating his position and be able to return home, while trying it out, he finds out there is still one use case which is not very convenient, is when the drone loses the beacon. Because in that case, you really want to return home. You're out of range and you don't have a beacon. And so he decides to like look into how he could like actually change the flight controller behavior based on like that new data, this Boolean, which is I'm detecting the beacon right now. And so he looks at the node which is doing all the flight controller of the drone and realizes it's actually a ROS2 node as well. So it's pretty convenient, but this node has the only specificity that it's actually a real-time node. So it's a node that doesn't allocate any memory, that has a higher priority on the system, and that can satisfy some real-time constraints. And so he goes into trying to understand how it could go. He feeds his new data to this system and sees that actually there is, as every real-time like code, a periodic deterministic loop. And so even if he receives a message, he needs to actually wait for the next update loop for this information to be taken into account. And everything is using pre-allocated message structures, so we still avoid the allocation of memory at runtime. And then based on that information, he actually wants to trigger the flight controller to say, okay, now you need to run the return home routine because I lost the beacon. And so it can then publish a status and the next update loop saying, okay, now I'm in return home mode, and that's nothing, sorry. And so ideally, you could build part of your systems in ROS2 being real-time, respecting real-time constraints, while still having that as being a single ROS2 node in your entire system, and keep developing your ROS2 nodes non-real-time for everything else. So if we go back on what we saw on this part, we introduced the notion of like life cycle nodes, which allow you to have deterministic startup, or also like take down node and bring them back up. We may have more detail about that in a talk from Karsten and Adam later. We also saw that we have currently launch files, we have these state machines. The thing we don't have implemented yet is actually have this launch system where you draw this box saying this is the same startup set of nodes, and they should be in the same group. We also looked into what the ROS1 bridge can do, and the fact that you could select which topics to bridge from ROS1 to ROS2, and like at which level in your robot you can set the bridge. You don't necessarily, it doesn't have to be all or nothing. You could implement a bunch of ROS2 nodes and keep a bunch of ROS1 nodes, and it would just work. Right now, we have two main configurations of the bridge, and that's something we would like to provide more possible configuration. Right now, you can have either a bridge that listens to everything on both sides, and if you have a matching topic, like a ROS1 publisher on foo and a ROS2 subscriber on foo, in that case, the bridge is actually takes these messages, converts them, and republish them. Or we have what we call a static bridge, which avoids having to subscribe to everything on both sides, where you can define a predefined list of topics, saying these are the topics of that message type, like each topic message type pair saying, I want to bridge this and only this. And so we would like to have something like more configurable in the future instead of being like anything that has a publisher and a subscriber on both sides, for example, TF. We don't necessarily want to bridge every TF message in both directions. And so finding something which is not that static, but like smarter on the dynamic side. For multi-robot, we mostly highlighted that all the features we presented before can become very handy in multi-robot systems. So I'm not going to talk much longer about this. And finally, we went into the embedded realm, which is totally possible with DDS, but not that easy because DDS frame with all these options of like quality of service have actually pretty big like UDP headers. Like the packets are pretty big to process. And that's why we looked into, some time ago, our colleague Morgan Quigley wrote his own implementation of the RTPS standard for microcontrollers to actually prove that it was possible to run them reliably on microcontroller. And now DDS has been, like the OMG, the group that is making the standard DDS, has been looking more and more into it, as well as the main DDS vendors, into providing a new standard called DDS XRC, which is DDS for extremely resource-constrained environments, and which should actually provide like a different wire protocol with much smaller headers, much smaller packets that should easily run on tiny platforms. And finally, the real-time support. So we talked very quickly, the same thing. We did that experiment of like convincing ourselves that by being able to pass in custom allocators to an entire system, we could have this proof of concept that like we have nodes publishing and subscribing under a very, very stressed system, and they still meet the deadlines. We don't test it on our everyday CI, and we don't have system running real-time kernel on a daily basis. So it's still something we would like to spend more time making sure that we can support a wider range of like real-time kernel or real-time operating system.
All right, getting back to the example we saw before where Rob was adding the second camera and the stereo image processing. And I mentioned that, like, of course, now you have two cameras and they both need to be communicated to the stereo pipeline. It's going to be overhead. So actually, Rob also notices that his system gets more sluggish and needs more CPU. So it's because both of these messages have to be serialized, copied towards the pipeline to be processed. And since all of this is running on the same machine, in ROS1, you probably know the nodelet concept. So, well, if the person would have written it as a nodelet in the first place, it would be nice. But in ROS2, this separation between a node and nodelet doesn't exist anymore. So you will be able to just, in a UI, for example, draw a circle around your three nodes and say, hey, these three processes actually should be relocated in a single process. And then they are able, once they are shared within the same process, they don't have to copy messages anymore. They can just pass raw pointers like zero copy style. And that's very convenient because you don't want to make that decision at programming time, because during development phase, it's really nice to have them separate, because your trade-off is if one of the nodes dies with a seg fault and it's running in a single process, the other ones are gone too. So it's like during development, you want the separation and the fault isolation, but once you're pretty confident in your code, you might want to really benefit from the performance improvement and put them in a single process. And for convenience, of course, Rob should be, at the end of the day, be able to save this setup after he has modified it as a new launch file, replace the existing one, so next time he starts the drone, he doesn't have to reconfigure it again. It just comes up the same way. Talking about like fault tolerance and error handling, so we had the example before where one of the cameras didn't work, so manual debugging is always like painful. So what we want to have is that the diagnostic system is able to tell you, hey, something is not right. You specified you want to have images with 30 frames, but they're not coming at that rate. So you actually get an event which says, oh, your publishing frequency, for example, doesn't meet the criteria you specified. With the lifecycle Mikael presented before, we can now react on that event and can say, oh, wait, take a step back, put all nodes back into inactive to figure out what's wrong. And maybe we just say, well, the left camera looks fishy. Let's just kill the process and start a new one. Maybe that already fixes it. So that would be the easiest and simple fallback behavior. But it turns out before you can activate the node again, the node says, hey, I'm still not ready because I can't talk to the device anymore. Maybe the cable got pulled out, so you just can't resurrect like camera left. So you're just stuck with only one camera. So you could implement a second fallback behavior which then says, well, dynamically, I know there's only one camera available. Let's just stop the stereo pipeline and load up a monocular image obstacle detection pipeline. That might perform worse than the stereo one, but still better than nothing, because better detect every second tree than no tree at all. So you end up with that setting, and for that one, you need the notifications as event, and you need to be able to dynamically start and stop nodes at runtime and have that introspection and configuration at runtime.
So now Rob and his friends are doing testing outdoor, and so Rob is doing his test flight as usual, like driving his drone around, and his friend involuntarily starts a launch file on his machine to create an image viewer. And he actually notices that he can receive the image on the image topic easily and like actually see everything. And he's like, yeah, that's interesting, that's convenient, but maybe not a great thing. And what if I start a joystick? And so he starts a joystick, and he actually realized that he can take over the drone, which in that case he successfully landed it, but could have been another outcome. And so he's wondering, like, how could I actually prevent people from tampering with my system, because that can be pretty dangerous. And so what he thinks of is, like, for people's privacy in general, I don't want anybody to be able to get access to this image stream. So what I'm going to do, leveraging DDS security, which is an extension to the specification, I'm going to say that I want this topic to be encrypted. And then he starts his node again, and unfortunately he doesn't have the key. So he cannot read anything from the topic. The other thing is that as a user, I should not really care if people can see the commands I'm sending to my drone. Like if someone is sniffing my commands, that shouldn't be that big of an issue, as long as I'm the only one able to send commands. And so in that case, it's more an access control and authentication part for data integrity, more than an encryption that we need. So in that case, we're going to turn on authentication only. And so if we start another node, like the access is going to be denied and no way to take over the drone.
Right. With the second to last slide, we might push the example of Rob a little bit, because he might not get into validation and certification as his hobby. But we just wanted to highlight, since that's an important thing once you get to a certain stage and you want to like make sure your software works, if you want to sell the product, if you want to use it in like serious environments, that there are multiple things which we think ROS2 makes it easier for you in the future. First of all, it builds on top of like a communication standard. So there is certified DDS implementations you can get. So that's already a big plus, because you don't have to do the certification yourself. In the future, there will hopefully be components which you can just buy which have certification, or maybe somebody open sources them and you just have a certified version which you can just get, which talks DDS natively. So it's easy to take one sensor from one vendor and an actuator from another one, and then you only have to care about the thing putting this together. There's also the components on the software side to make these things talk together and do something useful, which need certification validation. Maybe those are being provided in the future too. Then the user will always end up, as we heard in the previous talk, put his own thing on top and actually validate his own application. Only having the pieces validated or certified is not sufficient. You always have to look at your specific application. What we think is beneficial here is that by using a standard under the hood, it becomes possible to take already certified subsystems, which reduces your effort to certify your complete application. And due to the modularity of the software, you are also able to cherry pick what you need. If you only need a fraction of what the stack in ROS offers you, it should only be necessary to pull in those pieces, because every extra line you pull in, which you might not even use, will make your certification process way more expensive. And you will pay for something which you don't really need. So to recap the last section, we saw the dynamic choosing of your process layout, which is important to trade off like development and production use cases. And while that is already possible technically today, we don't have nice support in the tools. It's always like more things we wish we can do. that, for example, in a launch file, you can easily configure that and just like on the fly, like switch it. Then there was the event-based system for fault detection, which then we have the events, but you need something to act on the events and do something useful with it. And Mikael mentioned the DDS security spec, which is very good that it already specifies encryption, authentication, and various other things. I think there will be more talk in another presentation about how to configure that. And while none of the stuff in ROS2 is certified today, of course, we think that it's still, the direction is beneficial to make that step in the future easier and hopefully less cumbersome as it is nowadays because of simplifying it and using already existing standards. All right, that gets to the end of this slide. While we talked about a lot of the use cases, when you ask questions, you're not limited to asking questions about ROB. You can also ask any other technical questions, of course. Thank you.
All right, so as before, please step up and ask questions. We'll take the first one here from Josh.
Yeah, so I had a question about the implementation on embedded hardware. I know there aren't any devices that support DDS out of the box on the hardware yet, but when those become available, who's going to handle the certification of those as ROS certified? Would that be OSRF or is it DDS certification? How does that work?
Let's probably say multiple people, as in the previous talk. So it depends. I mean, there are certainly commercially available implementations which you can nowadays like buy. And you basically not only, I mean, the software is very similar to what they have as a non-commercial version, but you basically pay for the certification. You could certainly do the certification yourself, but it's usually very expensive and a lot of effort. You need to prove basically every single step in your software. So in the future, we hope that some vendors will already provide certified versions. It would be great if one of these options is open and doesn't cost you like big money. Somebody probably has to do the development, and a couple of people probably have to get together to pay for the certification and then publicize that. But you will still need to like certify your application on top afterwards. But after that, that should hopefully be much smaller.
Okay, great, thank you.
Let's go to the other side.
Hi, thank you for all this work on this stuff. It's really cool. Do you have a time projection for this? Do you have like a timeline?
Which part?
Not today. I mean, that's always the difficult thing. We have done like plenty of alpha and beta releases. The goal is that we will release a first version you can call stable, you can call the first official thing which gets a real name, not like beta. But it always depends, right, what you want to use. If you currently have the use case of doing pub stuff, request response, and you use C++, and since the latest beta also Python, and you pick one of the vendors which we currently support, you might be good to go to take beta 3 and like start working with it right now. If you need extra features like actions we currently don't have, and there's plenty of other things on the roadmap, then it might be later. Some of the items will be ready by the end of the year, but I'm pretty certain that that will not be everything we have on the roadmap currently. So it really highly depends on what feature set you're looking for, if it's going to be this version, the next version, the next version. But the goal is to, after the end of the year release, to get to a regular release cycle like in ROS1. We'll probably not pick a 1-year schedule because the development pace is still much higher and many things change. So it's going to be shorter, probably half a year, plus minus, we'll see. But that's the goal, and continuously work on adding more features and, yeah.
Okay, we need to get into more questions. I'll also just add that ROS2, just like ROS1, is an open source project. You can make it go faster by contributing to it yourself. Over here.
Hello, thank you for great presentation. I have two simple questions. The one is which versions of Python are going to be supported in the ROS2? And the second question is that how can we manage the different versions of Python code in the ROS2?
So Python is going to be supported, and is like supported to some extent. Like today, we have like a client library in Python on ROS2 beta 3. Different version of Python. Mostly, right now we pinned down we're using Python 3.5. Okay. So we're not planning on supporting Python 2. And And yeah, so hopefully, like, then we may like bump the version at some point if we really want some features which are only in Python 3.6. But for now, Python 3.5 should be like a good target. And so that's part of the thing. Like another way people can help to like complete what Brian was saying is a lot of people want to port some ROS1 packages to ROS2 today. And so sometimes some features are not here, but there is a lot of work that can be front-loaded on the ROS1 side that works very well in ROS1. And on the Python side, make the code work also with Python 3 is a pretty good start. So we will have Python support. We do have Python support already, and we are not planning on dropping it.
Okay, thanks so much.
Okay, let's, Tony, do we have any online questions from the live stream? You do? Okay, well, come on up, and while you're coming up to this side, let's take a question from over here.
Hi, maybe this isn't specifically your domain, but you mentioned a couple times, oh, this drone that happens to be ROS2 compliant or whatever. So robots, drones, and peripherals that are ready out of the box, do you have any plans or thoughts in actually listing those somewhere where you can easily find them? Or
So right now there is no official hardware publishing ROS2 messages, like DDS messages out of the box, like at least in the ROS2 message format. If, like, when we actually reach the point where people do ship hardware speaking ROS2, we would be very happy to like list them on the wiki or whatever, the same way we do for robots in ROS1. But right now, the only hardware that speaks ROS2 out of the box is maybe our friends from early have some, otherwise more like our hardware, like in-house to like actually experiment with it and show that all this auto-discovery and everything can work out of the box when you plug hardware.
okay, but in the future, you'll have that list.
Yeah, if like, it's exactly the same thing as in ROS1. We will have a website where people can contribute. Any companies that like sells hardware which supports ROS2 or which like speaks ROS2 out of the box is more than welcome to advertise it on our website.
Great.
Okay, we'll
maybe one short remark, because we always say ROS2 compliant, right? And we often mention DDS. That's the choice we currently have in our default implementations. We have 3 different vendors we support. But actually, external groups have like just implemented the same interface which we use for abstracting that with a completely different communication protocol under the hood. So it's difficult to say ROS2 compliant. You need to always know the ROS2 using DDS, and then you have like different vendors which will interoperate, but it could be a different implementation all along.
All right, we'll take one online question, and then you'll be the last one. Go ahead, Tony.
Okay. Because we are doing the live stream, so we did a questionnaire before the conference, and I think Brian got the results. There are more than 60 people interested in ROS2. So my question is, what's the timetable for ROS2? Because lots of people are looking for the, the released version, because now it's the beta 2 version, is it? So do you have the timetable for ROS2?
Yeah, sorry. So the latest one was like beta 3 last week. And I think it's always like incremental steps, right? So in beta 2, we already had a little bit of Python support, for example, and we got tickets like it leaks like Titanic, which was right. So the beta 3 made like huge progress on that one. So Python support is now better. And there are many things which we'll work on by the end of the year. But as I said before, it highly depends what you call ready for your use case. Are we ever going to ship a like final version and stop working on it? Probably not. Based on the experience with ROS1, there's always more stuff to improve and like either add on top or change and upgrade and improve. So yeah, I think it highly depends. Hopefully the release by the end of the year will be something which way more people can adopt and actually build on top. And also start their process on like getting their software on top, working with it either due to migration or using the bridge.
Okay, thank you.
All right, thanks. One last
We
question.
do encourage people to ask questions about, like, on the website or on the repos to let us know which are the features that are like necessary for them to start using ROS2. Because even if we're not going to spend time next month implementing them, we try to have a lot of design documents to allow people outside our organization to contribute these features. And so we're more than happy to answer questions on any issue tracker.
Yeah, okay. We will try our best to contribute to ROS2 as well. So yes, hopefully we can push that, go forward together. Okay, thank you.
All right, last question.
Hi. How do you communicate this lifecycle state? Is this some kind of default topic each node has?
So you have the option. I mean, you can either make a normal node which doesn't know about lifecycle, or you can implement a node which is aware of the lifecycle. And the lifecycle is actually pretty close to what's used in ROS and other projects. And it's basically exposing a service-based interface. So you can externally look at the component and you know that it has a lifecycle, and like, you can trigger state transitions and get notifications for that. Is that what you were aiming for with the question?
Yeah, so my question was, is this a DDS topic then, which is communicated? So each node has a default DDS topic for a lifecycle?
Yes, it will have a topic where it tells you when it changes the state. That will be published over a topic on the DDS level. And you will also have a service on the DDS level where you can say transition from unconfigured to inactive, and the node can either like accept that because it's possible, or it might reject your transition request.
Okay.
Yeah. But as I said, like there will be a lot of tooling around where you want to build like launch integration, which starts up all the nodes, triggers them all, moves them all to the next state, things like that. There's still like many things to build on top to make it convenient for the user.
All right, we're out of time, so let's thank the speakers again.